Welcome students, welcome to expert tutorial. As you know that we are discussing about some important topics for your upcoming semester examination. So today we will discuss about the very important topic PN junction diode. So let's start. So what is PN junction diode? Basically a PN junction diode is produced when one side of an intrinsic semiconductor is doped with donor and other side is doped with acceptor impurities. So this picture is basically a PN junction diode, and you can see that in the left hand side there are P type material. This is doped with P type material and this is doped with N type material in the right hand side. So in the left hand side the holes are the major carrier here, and in the right hand side the electrons are the major carrier here, and due to the different concentration of the electrons and holes in two sides, some electrons from the N region diffused into the P region and some holes from the P region diffuse into the N region. So in both the cases, when an electron recombines with a hole, their effective charge is neutralized. So near the junction only immobile charges, that is only immobile impurity ions are left. So thus a thin layer is developed that is depleted of any kind of charge carrier, and this is known as the depletion region. So basically this region is depleted of any mobile charge, that's why it is known as the depletion region. And you can see also this is the circuit representation of the PN junction diode. Now coming to the biasing of a diode. So there are two types of biasing conditions. One is forward bias and another one is reverse bias. So what is forward bias? Now if the positive terminal of the battery is connected to the P side, that is you can see in the picture here, this positive side is connected to the P side and this negative side of the battery is connected to the N side. So this is known as the forward biasing of any PN junction diode, and this is its symbolic representation. You can see in the picture, this is basically the symbolic representation, and this biasing voltage, it exerts a force on the holes of the P side. So there are holes in the P side and electrons in the N side. So this biasing voltage exerts a force on the holes on the of the P side and on the electrons on the N side. So they move towards the junction, and hence the width of this depletion region reduces. So and what about the reverse bias? This is just opposite to the forward biasing. So if the negative terminal of the battery is connected to the P side and the positive terminal of the battery to the N side of a PN junction diode, then it is said to be in the reverse bias. So this is the picture of the reverse biasing of PN junction diode, and it is its circuit representation. So now we will discuss about this is very important, very important for your upcoming semester examination. The VI characteristic of the PN junction diode, forward and reverse bias characteristic basically. So if we discuss about the forward biasing, this side, that is the right hand side, is the forward biasing of the graph, and this is the reverse biasing of the graph. So if you look into the forward biasing region, here the current increases very slowly in the first few voltages. The current increases very slowly with applied voltage up to a certain voltage. This particular voltage is known as the knee voltage. So this voltage is known as the knee voltage. This particular voltage is known as the knee voltage. And beyond this voltage, beyond this knee voltage, the current increases very rapidly. So this is the VI characteristic of the forward biasing of PN junction diode. Now coming to the reverse biasing reverse bias characteristic curve. So this reverse current is very small and almost remains constant with the increase in reverse voltage, but when it reaches the breakdown voltage, this is the breakdown voltage, large current flows through the circuit. So this is basically the VI characteristic of a PN junction diode. This is very important topic for your upcoming semester examination. Okay, now coming to the application of a PN junction diode, and here the application of PN junction, here it is the application of a PN junction diode as a rectification, So rectification is basically the conversion of alternating current to direct current. So it involves a device that only allows one way flow of current. So a PN junction diode can be used in this purpose. So first, the simplest kind of rectifier circuit is the half wave rectifier. So this is the circuit representation of half wave rectifier. So this is the transformer and it is used to input AC voltage. So AC voltage is applied here and you can get the DC voltage output in this load across this load resistance. So this is the AC input and this is the DC output, that is the rectified output. So suppose the first half of the cycle, that is this one, this is the first half of the cycle. So if the first half of the cycle is applied here, so the terminal, this terminal becomes positive. So the diode is in the forward bias. So a current flows through the diode and an output voltage is obtained along this load resistance. Now for the next half cycle, the this terminal will become negative. So the diode will be in the reverse bias, hence no current flows through the diode and the output voltage will be 0 and it will continue. So we will get the DC output in this form. So this is basically the half wave rectifier. Now coming to the full wave rectifier, and this full wave rectifier, here in your syllabus this is bridge rectifier and this is very important. So the circuit representation of this bridge rectifier is this. So there are the 4 diodes are used here. This is the AC supply, this is the transformer, and the output voltage, you will get the output voltage across the load resistance. So this is the input voltage waveform, this is alternating current AC, this is applied here, and the voltage output after the rectification, this is, you will get in this form. So please go through this matter carefully, and this is very important. So thank you everybody.